Something extraordinary is happening in our universe, and scientists have been investigating it for decades. They've noticed that some galaxy clusters are moving in unusual ways. Now scientists believe that there exists something mysterious beyond the observable universe, which is pulling the huge galaxy clusters in our universe toward itself. Surprisingly, recent discoveries from the James Webb Space Telescope have added weight to this idea. These new findings suggest that something located more than 93 billion light-years away is exerting a powerful influence on the motion of galaxy clusters within our universe. So, let's explore what exactly this strange structure beyond the limits of our observable universe is and why it is causing some galaxy clusters to move in its direction. The standard cosmological model explains that our universe has been expanding since it first came into existence. However, this expansion is not like objects moving outward into empty space. It is the expansion of space itself. This idea can feel counterintuitive because there is no central point from which the universe is expanding. Instead, scientists understand that the expansion of space occurs everywhere at once, uniformly stretching the distances between objects. If we think about this expansion, it will seem as if everything in the universe is moving away from each other. But here a question must arise in your mind. If everything in the universe is moving away from each other, then why do we observe galaxies colliding? And why is the Andromeda galaxy moving toward the Milky Way instead of away? Well, the answer lies in gravity. When the gravitational force between two objects is strong enough, it can overcome the expansion of space. This is why galaxies that are relatively close to each other, like Andromeda and the Milky Way, can be pulled together despite the overall expansion of the universe. But on much larger scales, the effects of gravity become negligible compared to the force driving the universe's expansion. As a result, when we look at the universe as a whole, the dominant effect we observe is the expansion of space itself, causing distant galaxies to move away from each other. But in the 1980s, when scientists observed nearby galaxies, they noticed something strange. They found that galaxies in our part of the universe weren't just moving away from each other due to the universe's expansion. Instead, they had extra motion as if being tugged by something massive. To figure out what was causing this, scientists studied the movement of galaxies by measuring their redshift, which shows how light stretches as galaxies move. These measurements revealed that our galaxy and many others are moving at about 600 kilometers per second toward a specific area in the sky near the constellations Norma and Centaurus. This suggested there was a huge concentration of mass pulling them in that direction. The problem was that this region is hidden behind the Milky Way's plane, which is full of stars and dust that block our view. This is called the zone of avoidance. In the 1990s, astronomers used X-ray observatories, such as Rosat, to peer through the zone of avoidance and detect galaxy clusters in the region. They named this region of space the Great Attractor. However, the Great Attractor isn't just one object. It's part of a much larger structure called the Laniakea supercluster, which contains thousands of galaxies and spans over 100 million light-years. The combined gravity of all this matter, including both visible galaxies and invisible dark matter, creates the pull we feel. The discovery of the Great Attractor showed just how powerful gravity can be and that we can see its effects even in the large-scale structure of our universe. But wait, scientists have seen an even more surprising phenomenon in the universe, and they are not able to tell what the actual reason behind it is. In 2008, a team of researchers led by Alexander Kashlinsky made an intriguing discovery while studying the cosmic microwave background radiation. They observed that galaxy clusters seem to be moving in a consistent direction, converging toward a specific point in the sky. This mysterious motion of galaxy clusters was something no one had any clue about, and they named this phenomenon dark flow. Astronomers speculated that something must be causing this dark flow. Some scientists suggested the Great Attractor. However, further observations revealed that some massive galaxy clusters initially believed to be influenced by the Great Attractor were actually moving toward a slightly different area of space. This time, there was no clear explanation for their motion. According to Hubble's law, all galaxies should be moving uniformly away from each other, adhering to the cosmological principle. Yet, this mysterious movement challenged that understanding. The Wilkinson Microwave Anisotropy Probe played a significant role in these investigations, offering deeper insights. During a 3-year survey, scientists discovered that the clusters were moving nearly 2 million miles per hour toward a region in the sky between the constellations of Centaurus and Vela. This motion is different from the outward expansion of the universe. Alexander Kashlinsky, an astrophysicist at NASA's Goddard Space Flight Center in Greenbelt, says, "We found a very significant velocity, and furthermore, this velocity does not decrease with distance as far as we can measure. Matter in the observable universe just cannot produce the flow we measure." The scientists deduced that whatever is driving the movements of the clusters might be caused by a massive, previously unseen structure. Just because our observable universe lacks any gigantic structures with enough gravitational pull to create such an effect doesn't mean such structures couldn't exist beyond the observable universe. For all we know, the actual universe could be billions of times larger than the portion we can observe. It might contain all sorts of unknown entities or phenomena that remain completely beyond our understanding or detection. However, according to our standard cosmological model, the universe should be isotropic and homogeneous on a large scale. This simply means that the universe is almost the same everywhere, and wherever you look, you will see a uniform distribution of matter. In this case, the existence of a giant cosmic structure that causes dark flow should not be possible. But wait, the new discoveries from the James Webb Telescope are now challenging our theories. These discoveries have shown that our universe may not be the same everywhere, and scientists now suggest that the discovery of unexpectedly massive galaxies in the early universe indicates that colossal cosmic structures may have formed shortly after the Big Bang. Furthermore, the rapid expansion of space following the Big Bang could have pushed these enormous structures beyond the observable boundaries of our universe. These huge cosmic structures that exist beyond our observable universe may be the reason for this mysterious motion of galaxies visible in our universe. This is the only explanation scientists have for the dark flow phenomenon right now, and new discoveries from the James Webb Telescope somehow support this theory. On the other hand, some scientists have proposed that the mysterious movement of galaxy clusters might be caused by a massive black hole unlike any we've ever observed. However, recent observations suggest that if such galaxy clusters were being drawn toward a colossal black hole, their motion would accelerate over time. Instead, the dark flow displays a constant velocity over billions of light years, which contradicts the behavior expected if a supermassive black hole were responsible. This consistency in motion implies that other explanations must be considered to solve this cosmic mystery. Another intriguing theory posits that the mysterious motion of galaxy clusters might be influenced by another universe. This is rooted in the idea that shortly after the Big Bang and before rapid inflation, our universe was part of a cosmic foam, a bunch of bubbles floating in space. One of these bubbles expanded and grew into the universe we live in today. But what happened to the other bubbles? Scientists believe that other bubbles might have turned into completely separate universes, each with its own rules and mysteries. While scientists don't yet understand how these universes could connect or influence each other, this idea sparks an amazing possibility. The mysterious dark flow might be a sign that our universe is linked to a vast multiverse,